This video is on factoring methods. We're going to decide when to use what, and we're also going to compare different methods that I've seen over the years. So this is the flowchart. You'll notice how on the side here, we're going to always try to common factor. Then you'll take a look at what you have left, whether you have monomial, binomial, trinomial, or 4 or more terms. And then from there, we'll discuss it as we go on. So in this question, we're going to do GCF, or greatest common factor. So the greatest common factor is going to be negative 2x squared y3. We pull out a negative because we see negative is first, and 2 is divided into 2 and 10 and negative 6 evenly, and then x squared, that's the lowest power that is on a common base x, and y3 is the lowest power on the common base y. We cannot just divide because now we've changed the result. If we are dividing, we should also multiply. So now we're going to maintain the equivalence. Then GCF that stays in front is written down, and then these are going to be our leftovers. So this is just pure division here, so you could pause and double check that this is correct. Then what's left? What you want to do is look at the bracket left over and ask yourself whether you can divide this or factor this more. This is a trinomial, so we're going to check the variable pattern. So with trinomials, we're going to have first term, last term, and the middle term. The rule is for any type of factoring to occur, we need the first term to have even power on the variables and the last term to have even powers on the variables. And then the middle term has to have half of each of the powers. So take a look, this is x to the 4 here, then this middle one has to be x squared. If this is x to the 6, then the middle one has to, y to the 6, this middle one will have to have y to the 3. You'll understand why this pattern has to work this way when we actually get into the factoring, or maybe you've already noticed that that's the case. So if we look at this leftover bracket here, and we're asking ourselves, can we factor this further? The answer is no, because the variable pattern does not match what we just talked about. Let's look at another example. Here we have no common factor, I believe. So the reason why, 27 is made out of 3 3s if you multiply them, and 8 is made out of 3 2s. So there's nothing in common between those two terms. So overall, there will be nothing in common. And because we have 4 more terms, we're going to do factoring by grouping. So often students place the bracket around the groups this way. I would discourage this because now it looks like 2 binomials that are being multiplied together, and that's going to yield a completely different result. So instead, when you're grouping them together, just put the bars on the bottom so that your attention is on the first 2 terms and then the last 2 terms. So looking at the first 2 terms, what is in common is 9n squared, and the leftover of that would be 4n minus 3. And this sign that separates the 2 groups will always be the one that will go right there. So please don't lose this sign because it's not going to be factored yet until we do one more step. So what's in common between these? So if these are the 2 terms here, the first term is a negative, so negative gets pulled. 8 and 6 get divided by 2, so it's negative 2 that we're pulling. And so this happens to be the same leftover as we had in the previous grouping. And this is actually good news because that means we can pull out this common bracket out of the question, and we'll have 4n minus 3 multiplied with these leftovers. Now, this might be too fast for you because the steps were not shown. So let me show you a little bit more steps to guide you why this above actually is true. So here's the question again. So when we're grouping these two together, we're going to think, what do we divide by? Well, we already talked about the fact that it's 9n squared. So you can actually show this division and multiplication. So then this 9n squared stays in front, and this division gives you 4n, this division gives you negative 3. Then on this side, we're going to divide out negative 2. But whatever you divide by, you have to also multiply in the front. And so this would be negative 2. These divided gives you that. These divided gives you this. Then we're going to show one more step of how does that line become this line. So what we're going to do is think in this term here and this term here, terms are separated by minus or plus signs. So this is the separation here. What is in common? What is in common is the actual bracket itself. So we divide this term by that bracket and this term by that bracket. And whatever we divide by, we have to multiply in the front. And so this multiple in the front is written just once. And then what's left over is that these divide out. We have just 9n squared, which is here. These divide out, so we have just -2, which is here. Now I'm going to take that answer that we had and place it over here so we can discuss, can we factor more? So this bracket and that bracket, they're both binomials. Now we need to decide, is it perfect cubes or perfect squares, or maybe neither. So looking at the first bracket, it is linear because there is no exponent on the variable. So that one we cannot break down. The second bracket has an exponent of 2, so potentially you could break this down. So is it two perfect squares? Well, 9n squared is a perfect square term because you could say 3n times 3n is this term. But 2 is not a perfect square number. So if you're trying to factor using only integers, I would say that you cannot factor more at all over integers, but that's not the only type of number that we have seen. There are other types of numbers out there. For example, we could say that it is actually two perfect squares. That second bracket is two perfect squares, as long as we're allowed to use square roots. For example, root 2 times root 2 is technically also a 2. So we could use difference of squares using irrational numbers. We'll leave that for now. There's going to be another video discussing how to do that later.